All right, lesson 2.2. What are we going to take a look at today? It is, if you could read the little top line of the graph, we're changing linear and exponential functions is what we're looking at today. Our learning goal is that you will be able to construct functions of the real numbers that are comparable to arithmetic and geometric sequences. Specifically, we'll do that using linear and exponential. So I'm going to go ahead and put that here, though it's not a part of it, just so you know. Arithmetic is similar to what type of function? Linear. And a geometric is similar to an exponential. So today we're going to start talking about exponential functions and what they're used for. We'll get there since that's going to be new for us this school year.
It's just linear on the package.
Yeah. All right. Well, thanks for the correction. So they're comparable to linear and geometric sequences, or arithmetic and geometric sequences are comparable to linear and exponential. And here's the word here: functions. You would not say a sequence for linear or exponential. You would say function. So there's kind of the trade-off in words there. So linear and exponential functions. All right, so how do we do that? Well, we're going to start first with linear or arithmetic. So you may remember from last class. You may remember from last class the equation for arithmetic sequence. What was that arithmetic sequence formula I gave you?
AN equals AK.
It was AK. It was plus N. No, not N. D for common difference times N minus K. Okay, so they actually follow the same pattern, both arithmetic and geometric. It starts with AK, and then because this is adding, you add the common difference. Whereas on geometric, you're multiplying, so you multiply their common ratio, and then it's always N minus K, N minus K. That follows in parentheses. Geometric gets raised to a power, but that's neither here and there right now. So there's the formula for arithmetic. Now, what I'm going to show you here is the point slope form of a line. The point slope form of a line was this, where you had your m times, the way we wrote it is x minus, and I'm going to use this x1 rather than k. I could use a k. I'm going to use x1. And then, so it was the slope times x minus x1, and then on the outside plus y1. Now, I want you to see how comparable these two are. Y1 is in the place of what over here? What is all on its own? AK. So Y1 and AK are comparable. If you want to make that little note there, Y1 and AK are comparable. Now, the X1, what is in place of X1 over here? K. So X1 and K are comparable. So it says the point x1, y1 for the linear function is comparable to the term of k, comma, ak for the arithmetic sequence. So that's how we get from one to the other. Now remember, the domain is going to be different because a sequence is not continuous. I don't know if y'all remember that. You don't have middle terms, you have only integer terms. Okay, so now let's look at a exponential function. An exponential function is comparable to a geometric sequence. Consider the following. So let's fill in our geometric from last class. Do you remember geometric? What was our formula there?
GK.
Okay, and I used it A. You want me to change it to G? Okay, so GN equals
GK plus
K parentheses R. That means it's multiplying times the common ratio. N minus K. And so I'll need to switch this to a G as well over there. You can go ahead and switch that to a G. Okay, now on an exponential, what does an exponential look like? Well, here's the formula you get today. It's AB to the power of X minus X1. Actually, they don't use an A. Sorry, I'm looking down here. I'm cheating. Your Y. No, I'm gonna still put the A there. No, I think it needs a y1 here. I know it's confusing. We're going to use an a. That's sorry. Back and forth, back and forth, back and forth. Can't decide what to do with my mind. I shouldn't have printed it like this. I should have put, instead of y1, I should have put an a there. So what we do is you're actually going to see me write it this way. I'm going to just say, I'm going to write it both. Is x minus x1. That's kind of, and the a is the initial term there. Okay, so that's usually the letter we see. So it'd be x1 comma a. Trying to fill it in like the notes, but that's not the way I'm going to write it all year. I'm going to use the a, and almost everybody uses an a. A refers to your initial term, your initial y. So again, these are similar. If you compare, these equations are very, very similar. A big difference is exponential. It's going to be continuous. The graph is going to be continuous. This is going to be a continuous function. Again, just like linear, as I was saying, this will be a continuous function. Where the word is for sequences is that these would be discrete. Discrete would mean it's not continuous. It's going to be the integer values. And the whole numbers. Discrete. Yeah, that means it's not going to have the decimals in between. Say it again. Well, you're not going to have like an A 3.2 term. You'll have an A3, you'll have an A4, but you won't have like an A 3.2. That's what I mean by discrete. It'll be whole numbers. Okay, so right now you might be going, oh, what the heck does this mean? Well, let's jump right in and figure this out. Okay, I have a slide that you can look back at, just properties of exponentials. Growth, it's always increasing. I want you to note this. This is always increasing. See that? What can you tell me about decay? It's always decreasing. Notice this does not say that, so put always increasing here. Always increasing. And it also has concavity. Does this look like it's concave up or concave down? This one's concave up, always increasing and concave up. Go ahead and throw that on there. Okay, what about exponential decay? It's always decreasing. Always decreasing. And it is concave down. No. This is concave up as well. All right. We are going off of opposites too much without looking at the picture. Look at it. Is the slope increasing or decreasing as you go? The slope's not decreasing. The slope is actually increasing. The slope's getting greater and greater and greater as you go. So it's still concave up. Now you could have a negative initial term, which would reflect these over, and then you get concave down. So you will see that, and I'll show you that next class. All right, so let's say the domain of a sequence, this is what I was talking about a second ago, will not always be the same as the domain of its corresponding function. Consider the following. When you look at this geometric sequence, this has a discrete domain. The domain is discrete. What do I mean by that? It's just the whole numbers. So does this graph exist in between the whole numbers of your domain?
No.
No. So put on here, you can say that the domain is discrete. Is discrete, that's the word, discrete. And I want you to know that this domain would be written something like this. You'd say your domain is, what's the initial value here?
0.
0, and it could continue on forever. And so they use the letter n, so I'll use n here. I'll say that n is greater than or equal to 0, but I'm not going to do NER. I'm going to do NE and a W. Do you remember what W meant? Whole numbers. Yeah, it's and because we don't include the negatives here. It's only the positive numbers or 0. So that would be the domain. Now on this, is my domain discrete?
No.
No. What do you call it if it never stops? If it's just, I don't want to use the word. I don't know what else there's synonyms to use. If you don't ever pick up your pencil, it just continues on. continuous. This domain is continuous. Domain is continuous. So when we deal with the functions, we'll have a continuous domain. And so this domain, they use the letter X here. So I'll use an X. So this, I shouldn't have used X. I should have had on this graph an N there. And this would be G of N. But anyways, we'll say X is, now can it be only positive numbers?
No.
It can be negatives as well. So we'd say X is all reals. And it's all reals. It's not just the whole numbers. It's all reals. It's everything in between. So there's a difference between a sequence and a function. Sequence is discrete values, usually 0 or greater. Whole numbers, 0 or greater, and then all the whole numbers. Whereas a function's all reals typically, most often. All right, let's look at example 1 here. It says a function has the following coordinate points. Could the function represent a linear function, exponential, or neither? We could just graph it. Now there are some ways. I'm going to go by formula here that I gave you last time. To find a common difference. What was the formula to find a common difference from last class?
First term minus, second term minus.
You take any term and you subtract previous term. Okay, so on your notes here, just put an minus 1. That meant you take any term and you subtract the previous term. And the deal is, it should be the same on any one. Now, when you talk about sequences, now as I convert, by the way, to functions, you wouldn't use necessarily these symbols, but you'd follow the same pattern. What wide value do you want to use first?
1.
Okay, that one we don't have a previous one. So how about 4? What is 4 minus 1?
3.
Okay, so we're getting a common difference of 3. Now, is the second, if I test it again, let's test again here. If I test again, will I get 3? If I take 16 and I subtract 4. Okay, so is this common?
No.
Not a common difference. So this is not common. That's not a common difference. Not a common difference. So it's not arithmetic. Or in that case, it's not linear. The way I've done it with linear is we've done change y's this way. We'd say, how much should we change going from there to there?
4 times 4, 3.
We increase by 3, and then how much should we increase here?
12.
12. Is it linear?
No.
No. Now, we're not checking quadratic, so I don't do a second difference. I'm not checking quadratic here. So, not linear. That's showing you 2 different ways. It's not linear. Those are not the same. So if it's exponential, here's how we would know it's exponential. We'd have some type of common ratio. So now the formula for a common ratio, if you remember, is, let me divide this up so we can see that I'm doing something entirely different now. Let me come over here. If I checked for a common ratio, the formula was R equals AN, not minus, sorry. Someone correct me.
AN divided by AN.
There you go. And we use G's. So I'm going to correct, that's it. I'm going to correct that too. There we go. We used that last class. Now I'm going to probably mess up this because for 10 years, the regular pre-cal textbook only uses A. So you're going to have to just correct me with the G's. I'm going to make a lot of mistakes on that. Old habits, you know. So on this one, what term do we want to use first?
Let's use 4.
How about 4? And then we want to divide that by 1. And what we're going to test is to see, will that be equal to, what is that?
4.
4. Okay, we want to test again. And this time, we're going to say, will that be the same thing as 16 divided by 4? What do we get there? 4. Is that a common?
Yeah. Yes.
This is a common ratio. That's the name. Common ratio. So we got the letter R in geometric. Okay, so now when we go to writing an exponential function, this one just says, what does it represent? This represents it's exponential. This is an exponential function. Now, if you wanted to get your equation, since I haven't taught you as much on exponential, I would just use the a geometric sequence. And I would plug in values. What do I mean by that? If you wanted to get the equation, remember how I said Gn equals G K times R to the power of N minus K? Do you remember this from last class? Remember that formula? What you could do to get your exact equation is you plug in the value. So I'll just use 2 and 1. I think that'll be the easiest. What is that 2? Where does that 2 go?
You could say that it's X would be
This
A,
could be a K. This would be
A.
GK. This could be N and GN, if that makes sense. So I'm just going to solve this for you one time so you see it done. So what I will do here is I'll plug it in. So I'm going to say that this is going to be our K and GK. That'll be N and GN.
You can label.
Yeah, let's do that. That'll be great. So what I'm going to do here is I'm going to say that 2, 1, that's going to be our K and GK. Then 3, 4, that's going to be our N and GN. And we can solve for there to find whatever else we need.
All right.
Okay. Actually, since we have the R, I don't even think we have to plug in this one. Now that I think about it, watch this. I'm overthinking this. What is GK?
1.
GK is 1. Perfect. What is our R?
4.
4. That's why I forgot we had the R right there. I wasn't thinking. So we don't have to solve this. We can just leave it like this. Well, I'm going to leave N, but what is our K?
K is 2.
K is 2. And this would equal GN. So let me scribble that out. Whoops, my stuff timed out. There we go. I'm back. And that would be our equation right there. Now that's in as a sequence. If you want to write it as a function, and that's probably how they want it, as an exponential function, you would just change it to, instead of GN, you would say f of x equals. Do I need to write 1 times anything? Do I need to include that 1? No, so you can just write it as 4 to the power of N minus 2, like that. And you can say that's the exponential function right there. How about that? I'm going to move that over. And that's your answer right there. Okay. Now this is part A, so let's load it up and do it again. How about part B? What do you think? Could this be linear? I'm going to do the change of y's. How much does my y change? Going 3 to 7?
4.
How much does my... Is it linear?
No.
It's not linear. To see if it's exponential, we need to do the yeah, go ahead. Okay, to try exponential, we need to look for a common ratio. So how do you find a common ratio?
It's R equals GN and then divided by GN minus 1.
That's right. So we're going to test to see if these are the same here. 117. Okay, so that means the GN represents the Y values. So take a Y value and then divide it by the previous one. So let's just take 7 and divide it by 3. Is 7 divided by 3 going to be the same thing? Will it be the same thing as if I took 10 and divided that by 7? Will those be equal to each other? If I take 7 divided by 3, then take 10, divide that by 7.
7 divided by 2, so 2/3, and then 10 divided by 7 is 1/3. So no.
Are those the same?
No.
No, they're not the same. So if these are not equal, what have we established?
They're not. It's not neither. It's not a geometry sequence.
Not geometric. Sorry, for today's words, not exponential. So this is neither linear nor exponential. neither linear nor exponential.
There would be no wins.
Well, there are different types of sequences, different types of functions, but today what we're focusing on is linear and exponential. Okay, and let's try this other one right here. Let's check to see if it's linear first. How much are my y's changing by? And what about here? What can you tell me? This is a linear. So if it's linear, you could use the the arithmetic formula to try to solve.
Your AN equals AK plus B and then N minus K.
Yeah, let's say AN equals AK plus, did you say the letter?
D.
D, very good. D, N minus K. Okay, and as I was saying, since we know what the common difference is, what is our common difference?
A. So you just plug in.
We just need to plug in 1 point. So y'all okay with plugging in the very first point?
Yeah.
So we're gonna say this is K and this is
AN. I mean
AK, and we'll plug that in. So we'll have AN equals, what is AK? -1 plus, what's our D? 8 times N minus, what's our K? 3. I'm going to simplify this. So when I simplify it, I'll also change it to a function. So I'm going to say f of x equals, I will have, instead of 8n, I'm going to write it as 8x. So think with me here. What is, we know that's 8n. What is 8 times -3?
-24.
And that's got to combine with the -1. What's -1 and minus 24 more? Minus 25. That would be my equation right there. Okay, questions over how we did that? Now, I was able to use just 1 point because we knew what the common difference was on part C, and on part A, we knew what the common ratio was. If those were unknown, you'd have to use 2 points. Okay, so now let's go into example 2 here. On example 2, it says this. If we know a function is linear or exponential, meaning arithmetic or geometric sequence, then only 2 distinct values are necessary to create an equation or rule for the function. So example 2, it says it's known that f of x is linear function. So we know that it's linear. We know that it's linear, and it passes through those 2 points. So write an equation. So what's the thing we don't know right now?
We don't know the common difference.
Common difference, or translation into a linear. What represents the common difference on a linear function? What word?
Sequence.
No, I think so. On a line, a lot of times we might say the y-intercept. We might say slope. Which one we don't have? What's the common difference? The same thing as. The common difference would be the slope. Common difference would be the slope. So we don't know the slope yet. So to find the slope, how do you find the slope?
Y2 minus y1. Oh, change of y's over change of x.
Change of y's over change in x. You can do it that way. And so how much does my y change here? From 7 to -7 to 1?
6.
That's right. 7 to 1 is going to be, well, I did the 7 first. Let me rephrase it. It's 1 minus 7. There we go. The y2 minus y1. Okay. And then how do you find change of x?
8 minus 3.
8 minus 3. Yep. And so that tells us that the common difference is
-6 over 5.
And I said common difference. What could I also have said? Slope. The slope is -6 over 5. So at this stage,
Write down the arithmetic sequence.
if you wanted to use the arithmetic sequence, that's fine. You can also use point slope. Either one's fine. Because y'all haven't worked as much of your life with arithmetic, I'll use that so we don't forget that equation. You're going to need to have this memorized, so might as well work on it now. It's AN equals
AK plus B N minus K.
That's right. So it's always the AK can represent any term as well as AN, but it's like let's say the first term, the earliest term, and then next comes either the common ratio or common difference. If it's arithmetic, you add it. If it's a ratio, you multiply it, and then N minus K.
gonna use one of the 2 points that are given to us.
Yeah, we can use one. Now that we know the slope or the common difference, we can just pick 1 point.
1 and 8.
You want to use 1 and 8?
Yeah.
Is that the right way to saying it though?
8,
Okay, so let's use this as K and AK. You can pick either one. You should get the same answer. So we'll say AN equals 1 plus. Okay, so if it's plus and negative, well, I'm just going to change this to a minus 6/5 times. We don't know n, but we do know n minus 8. Good. We go to simplify.
Alright, we do negative 6/5n plus.
That is going to be a positive good when we distribute.
divided by 5.
Is that 48 divided by 5?
I just multiplied the top.
With a fraction, you multiply the top and you divide the bottom. What's 6 times 8?
48.
48 divided by 5. I totally agree. 48 divided by 5. Okay, to get it, I'm going to get a common denominator here for my terms. 1 is the same thing as, and what in terms of a denominator 5?
5/5.
1 is equivalent to 5/5.
Just subtract 5 from the top.
And I'm going to rearrange here. Plus 48/5
I mean,
minus 6/5 n. Okay, as I go to rewrite this, I'm going to transition to f of x terminology. So we'll say the function f of x is equal to, we usually do the slope first, so I'll do slope. Negative 6/5. I'm not going to use the letter n. What do I use instead of n? X. And then what's 5 plus 48? Plus 53/5. You could write it that way. Or do I have a common denominator?
yes.
If you preferred, you could write it as 1 fraction with 5 doing the dividing. Negative 6x plus 53. Whichever one you think looks better. I kind of like the lower, but whichever way you want it. Reload and try again. Reload and try again. Example 2, part B. It is known that f of x is exponential this time. So what I was saying earlier is, I know I didn't write the notes out. I just need to correct that for the future. But typically, I write the equation that you'll see it this way: ab to the power of x. That's the general form of exponential. They'll write it that way to you for you. I know on the notes earlier, how it turned out is I had it written as f of x equals, and it would have to be y1 b to the power of x minus x1. But truthfully, we write it like I did in red. That's typically how you would solve one of those. It passes through these 2 points. Write an equation for this. Okay, just since we haven't worked as much with geometric and you have to have that formula memorized, I'm going to use the geometric formula.
Gn equals gk times r to the power of n minus k.
There you go, times r to the power of n minus k. So notice the pattern is the same. You have, I wrote a gn, didn't I? G. Okay, the first thing that happens is the k term, and then it follows with either the common ratio or common difference. Common ratio multiplies, that's why this one's multiplying. Common difference adds, that's why that formula has a plus. But then it's n minus k immediately following. So now we plug in values. Actually, we need to find our r. We haven't done that yet. What's our r?
So divided by 5.
Very good, because the formula is an divided, not an, sorry.
Gn and then gn minus.
10 years is hard to correct. I'm sorry. Someday in the future, maybe 5 years from now, you'll watch a YouTube video and I won't make those mistakes anymore, but it's going to take a while to break that habit. Because I know in about 5 years, you're just going to be wanting to watch these videos. Yeah. Okay, that's our formula. So what is GN here?
Gn would be
12 and GN minus 1? 5. That means take any term, divide by the previous term. So we got 12/5. That's our R. So now which point do y'all want to plug in? 2, 5 or 4, 12? 2, 5. So we're going to say this is K, this is GK. So GN equals, what's GK?
5.
5 times
12 over 5.
12 over 5. Can I just simplify that right now?
2 and 2 fifths.
I mean, can I just multiply that right now?
Oh, yeah, 60 over 5, which turns into 12.
The answer is no because of PEMDAS. You were doing the math before thinking.
Oh.
You have to take care of the exponent before, and I haven't written the exponent. It would be n minus, what's our k? 2. You cannot multiply that without taking care of the exponent first. So the answer is no, you can't simplify that. Now, next class, we're going to learn about some tricks that we can do, but we haven't got to next class yet. So that's still in the future. So there it is. That's our equation. So now let's transform this into an exponential function. So as an exponential function, would I still say Gn? We'd say f of x. I would still have the 5. That would be our A term. Our B, our base is what B stands for, base. The base is 12 fifths. Raised to the power of, I wouldn't use an n anymore. I now would say x minus 2. And there's your equation right there. All right, let's take a look now at some real world applications. I've given you 2 formulas here. It says here in financial settings, most housing mortgages, wow, car loans, or any loans for that matter, credit cards, business evaluations follow exponential patterns. Knowledge of the following formulas is essential. You need to have these memorized. Okay, you have 2 different formulas shown here. The big thing I want to point out is this. When we talk about money, this A refers to the final amount. So let's just put this off on the side somewhere. A is your final amount. A equals, just add these in somewhere, the final amount. The actual name for P is principal. Do y'all know what principal means? This is the starting amount. As you go through, what do you think R stands for? The rate. Specifically in a financial setting, it would be the interest rate. I'll just say rate of growth or decay. T is time. Most often in years. N is the number of times. Number of times per, usually it's going to be year. If T is in years, per so I'm just going to say quantity of time. Number of times per quantity of time. So what do I mean by that? What words you're usually going to see are things like monthly. Your credit card bill, it's going to be interest rates compounded monthly. What does that mean? They say monthly.
Every month.
And once a month. And you're going to be looking over the course of a year. So N would be 12 because for 1 year, there's 12 months in the year. And so that's what I mean by N is the number of times. So you might see weekly. Do y'all know how many weeks there are in a year?
Like 26.
52. So it'd be 52. If I said daily. Okay, now on a different thing, if you're looking though, if this is not about financial things, if you're studying like population, especially like insects or something that populates really fast, the unit of time might not be a full year. It might be, or like bacteria, for example. If you're in a science class, you might have your unit of time be a day. And so if you're talking about T being 1 day, and I said hourly, now you don't find out how many hours are in a year. You'd say, well, how many hours are in a day? 24. And it'd be 24. So what the N means is the number of times per the quantity of time. Like meaning, if this is in years, then it's the number of times per year. If this is in days, then it's the number of times in a day, and so forth. Okay, those are your formulas. You got them down? All right, let's see how this right here might be one of the most important lessons for you. I know a lot of you just want to take this class to get your math credit out of the way for college, which is great. This lesson could be hugely impactful on your future, your financial future, how much freedom or lack of freedom you have in your future. So it's understanding these will really help you out.
There is.
There is no freedom. We are all slaves to something, I guess, huh? That's what Chris says. Mr. and Mrs. Jimenez found an educational saving account for their daughter that pays 5% interest compounded monthly. And they invest $5,000 for their daughter and make no other deposits or withdrawals. What will the value of the account be after 18 years? Okay, so the first thing you have to establish when you're working through these type of problems is which of my formulas do I need to use here? We need to use, what's the key word here that tells you which of the two formulas to use?
18 years.
Nope.
Compound. 5%. Oh.
Compounded monthly. Does that mean, I didn't tell you this, on this A PERT, E is a number. It's like pi. If I say pi, let me write this down. Go back to slide one more time. If I said pi, what do you think of that as approximately as a number?
3.14.
Great, y'all know that. Now, E is also a number. It's approximately 2.72 when you round.
What?
E is a number. If you don't trust me, go to the calculator.
Alright, just type in E again? No.
And you need to use the E on the far left. You see the far left that says e to the x?
Hold on.
You type that in, put power 1 to find out what E is actually. And so you'll see that it's approximately, when you round, if you round into the nearest hundredth, that would be 2.71 or 2.72. 2.72, like I said. But this is, if you keep taking calculus, you'll learn how to calculate E. But that's what this number is. For now, just take it as what it is. That's what the number is. Okay, it's 2.72. This formula, I didn't tell you this. This formula is used if something's being compounded all the time, continuously, meaning all the time, not stopping. This is used when you only compound a certain number of times per year. Okay, so on this one, it says it's compounded monthly. Does that mean you're compounding it all the time or a certain number of times per year? So we use the top formula, which was A equals P 1 plus R divided by N raised to the power of N times T. All right, let's go piece by piece. It says 5% interest. What is that 5%?
That is our rate of growth.
The rate. It's growing at 5%. Now I'm going to change that to a decimal. 5% is the same thing as,
0.05.
if you don't know the math, what you do is you divide by 100%. You divide by 100%, that's the same thing as dividing by 1. 100% is 1. So I'm not changing the problem if I divide by 100%. I'm dividing by 1. That doesn't change it. But if you cross out the percentage symbols, you can see that, okay, well, what's 5 divided by 100? It's 0.05. What you do is you move the decimal over 2 times. So it was a 5, move it left 2 times, you get 0.05. That's our rate.
And then our initial value would be 5,000.
Now, before we get there, I'm going to circle the word monthly. Monthly is telling you one of your variables. Which variable is that?
That's your time. Yeah.
That's not my time, it's my N. N is
12.
12. That comes from the word monthly. If you want to put that in parentheses, so if you look back later, you understand where we got N of 12. That's the word monthly. There's 12 months in a year. If they invest $5,000, now what is that?
That is our initial value.
Initial value. Which letter refers to the initial value?
P.
That right there is the P. Now for the calculator, we're not typing in a comma nor dollar signs. Just put 5,000. Make no other deposits or withdrawals. That means they add no money. They don't take out any money. What will the value be after 18 years? We finally come to the end of the problem. What is that? Is our time.
Or do we just keep it like that?
Okay, so now we're going to plug them in and we'll let the calculator do it for us.
All right.
We're going to solve for our A. That's the unknown. We don't know A, but we do know our P is 5,000. 1 plus 0.05 divided by N. What is N? And let me put this in here, years. Again, the reason we did months as 12 is because there's 12 months per 1 year, per quantity of time. So that, and then to the power of, whoops, what's N again? 12 times, what's our T? That's what we're going to type in our calculator. So we have $5,000 multiplying the base of 1 plus, if you do controlled divide, it'll give you a fraction. An interest rate of 5% that's being compounded monthly, which means per month, you would divide by that to find out how much is being compounded per month. And all this is raised to the power of 12 times 18. By the way, if you're using Desmos at home, you're going to have to put a parenthesis around the power to make it calculate right. Now, on my Inspire, you don't have to, but on Desmos, you'll have to put a parenthesis to make it stay in the power. Otherwise, it'll leave the power every time you hit multiplication symbol. Press enter. What do you get? Okay, now, how many decimals should we take if we're talking about money? Two. Let's make it educated. We're going to take two values right there. Screen capture. Oops. Oh, come on. There we go. And so we're going to say the value is.
Would you say A is equal to 12,207?
That's right. The final amount, the A would equal $12,000, $12,275, I should say, and 4 pennies. That would be our final answer. Yours cut off the decimal. Okay, so do this on your calculator. If yours are getting cut off, press the home screen, go to settings, and go to document settings.
It's 3 digits.
And that, I have mine on float 12.
Okay.
If yours is getting cut off, it's because it's on float something smaller.
Float 6.
That's telling you how many significant digits it's going to take. Just go up to 12. And once you do that, click OK. And then you can go back to current. Press 4 to go back to current. And it'll take you right back there. That'll get your calculator showing you more decimals. You might have to copy it and re-enter it if you just switch your float. Just press up twice. Press up twice, hit enter, and recopy it. And after you've changed your float, it'll show you more decimals. Okay, let's look at part B.
Take a picture.
Yeah. This page or calculator? Okay, go for it. Chris, you hanging in over there? All right, let's look at part B. It says, Mr. Rangel purchased Google stock in 2010. By the way, these are true numbers. These are not made up. This is true facts right here. The cost of Google, Google has 2 different signs. If you're ever interested in investments, you can look this up on your phone. I'll show you in a second how to do that. But that's one call sign. One's Goog and the other one's Google, like that, without the E. But that's what you look up. It was $14.90 on January 1st, 2010. On October 1st, 2023, the price of Google was $138.04. Now, here's the deal with Google. Does Google make money only once a month?
No.
Do they make it once a day?
No.
How do they make money?
Every second.
All the time. That's why we're not going to use the same formula. You see how this says use the continuous compound interest formula? That's because Google's making money all the time. So that formula is A PERT. A PERT. You see how it looks like A PERT?
Oh.
You're going to hear me say A PERT all the time because, among other reasons, it'll help you memorize it. You hear me say A PERT, this is the one that's happening all the time. E comes from the number of something that's being compounded all the time. That's where that number comes from, that 2.72. So
you do pi.
find the rate of interest. Okay, so here's what I'm going to do. On this one, I gave you different information. This first value I gave you was $14.90. Hey, stay with me here. What is $14.90? What does that refer to in the formula?
That's our initial.
That's the initial amount. The initial amount is $14.90. I'm going to take away the dollar sign. Okay. On October 1st, 2023, the price of Google was $138.04. Now, what's that?
Oh, that's our final amount.
That's the final amount. $138.04.
And then 14 years is your time frame.
And if you scroll on down, it says 14 years is your time. Approximately 14 years. Okay. Now notice I didn't give you a value for E. Why do I not give you a value for E?
Because we know where
It's not a variable. It's 2.72. We don't type 2.72 in the calculator. We'll use E. What's the thing we're missing?
R.
R. We're looking for R. That's what we don't know.
Really algebraic software.
Now, I haven't taught you how to algebraically solve this yet. So for today, we're going to use a calculator trick, but I will show you in the coming days how to solve this. So what is our A when I plug in all this?
138.04.
138.04. Sorry, 138.04. And that's going to equal
14.90 times E.
I'm going to just type it in as 14.9 into the calculator. We don't know R, but what is T?
14.
Okay, now be smart here. It's R times 14. What's an easier way to type in that calculator?
14R.
14R. Now, what we're going to do, whoops, sorry. What we're going to do is solve this because I haven't told you how to solve it. It's quite simple to solve, but you just haven't learned how to do that yet. So let's go over and solve this. So the solve, if you don't know, what you're going to do is you're going to press menu 3-1. I'm going to clear out all this. Press menu 3 for algebra, 1 for numerical solve. The value was $138.04. Is that right? That's the final amount. And that equals to $14. And you could do 90 cents if you wanted to. I'll just go ahead and type in 90. Press E on the left, the E to the power of X. And then 14R. So far, all I've done is if you're ever going to solve, if you're allowed to use a calculator and you're solving, never, ever reduce on your own. Don't do it because all you do is enter in your own potential error.
Yeah.
So that's why I didn't. If you're in solve, don't try to simplify anything on your own. Okay, now after you type it all in, before you hit this parenthesis, the very end, you say comma and you tell the calculator what it's solving for. What are we solving for? Are we solving for E? No, we know what E is. We're solving for R. Press enter.
0.15.
Okay, now you should have gotten. All right, you got an error on your calculator? You want to look at someone in next year's, figure out what you did wrong? Oh, did you figure out what you did wrong? Okay. Let me copy this over. That is the growth rate. Come on. So we discovered our growth rate is, I'm going to leave it at, I'll round to the nearest thousand. So I want to say our rate is approximately 0.159, which you could write as, again, approximately 15.9%. So that would be a rate. You could say it's 15.9% growth. And what we're going to see now is what happens when you change your growth rate from like an educational savings account at approximately 5% to a company like Google that's been growing at 15.9%. What would that do for your money? So on part 2 here, if the stock continues at this growth rate and Mr. Rangel's initial investment was $3,000 in 2010, what will his stock be worth at the end of 2030? Now, you might be wondering, why did I choose that number? A very particular reason. How old are most of y'all in the room?
Oh, 16.
Oh, y'all are 16. Some of y'all are 17. I was guessing the most of y'all would be 17 years old. Do y'all know how old I am?
29. 21 to 30. I'll give you like a 39, like
I'm
26.
I'm 37. So if y'all are, I'm gonna say 17. Some of you are 16, but if you are 17 and I'm 37, how many years older am I than you?
Like
20. Okay, now look at this problem. It's like if I started investing when I was your age with $3,000, What would the value be when you are my age sitting in this chair? That's what we're gonna discover right now. Does that make sense what we're doing? If you were to have, you work all summer, because y'all are 16, so let's say you work this next summer and you saved up $3,000 and you bought Google, and Google grows the same way. When you're my age and you got 5 kids and wife, husband, whatever's applicable to you, and because I know you're all are gonna have 5 kids like me. What will the
Hey, man.
what will the value be? That's what it's discovered. Okay, take some guesses. Take some guesses. What do you think it would be if you? Let's think back to the previous problem. On the previous problem, we invested $5,000 for 18 years, and 5,000 turned into $12,000. And I don't know if I really said enough about this. That means you worked for 12,000. Excuse me. Did you work for 12,000? No. You worked for how much money?
5,000.
5,000. That 5,000 worked for you. You didn't work for it. It's called passive.
That's income. Yeah.
It turned into how much money?
12,000.
12,000. So out of that, you worked for 5,000, and $7,275.04 was granted to you. So you felt like you worked for 5,000, but it actually became 12,000 with a little patience. Does that make sense? What happened?
18 years.
Okay. So how much? I know to y'all right now, 18 years seems like a long time. The older you get, the faster it flies by. Okay. How much do you think 3,000 will turn into over 20 years? So we did 5,000 over 18. Take a guess. What do you think 3,000 will turn into over 20?
47, that's 137. Yeah, like around, like, no, I feel like 6,000. 6,000.
Let's go find out. We know the formula now.
Is it 10,000? Around 10,000.
Here's what we're gonna type in. Shh. Board, we're not typing in. Our initial values change. What's our initial value now?
3,000.
This is now our P. So we're gonna say 3,000. Take away the comma and the $sign E. We now know our rate. Hey guys, stay with me. 0.159, and we know our time. How much time? 20 years. Let's go find out what that's going to be valued at. 3,000 E 0.0159 times 20 years. Press enter.
Golly.
What did I do wrong? I see what I did. I accidentally included an extra 0 in there.
Jesus, I was off. 3,000.
All right.
72,000.
All right. I want to make sure you understand fully what just happened here. I told you this class is very important for your life because it can change the financial future of yourself more than anything else. If you work this next summer, you're 16-year-olds, and you saved up $3,000 and you bought Google, and Google continues to be Google. It grows at the rate it's been growing. You can all buy stock. If you don't know that, as an American, that's one of the freedoms we have. If you're in a different country, you can't know. People don't just own the company. A lot of times, like China,
72.
China. That yeah, you're seeing the number. You earn $3,000. How much money did you work for?
3,000.
3,000. You're complaining the whole time. I'm flipping burgers at McDonald's for $12, and they should be paying me more. Well, you saved that money and you quit complaining and you bought some Google. And then you looked up, and how much work did you do for Google?
None.
Nothing. You don't do any work for Google, but you risk it. You risk it by saying, I think people at Google are going to make money, and I'm going to take what I hard-earned work for, my 30,000, I'll put it in there. And you don't touch it till you're my age. And you sit in this chair later and you open up your account. Is your $3,000 still $3,000? How much is it now? $72,000.
That's 3,000 now. Buy you all 100. You can buy you.
Language.
I'll see you all in 50.
All right, so we're gonna play this out for a second.
You're on the cents up to 3.
So we're gonna say this is equal to $72,000, $72,140, and how many pennies?
26.
26 pennies. Now let that sink in for a moment. Let that sink in for a minute. One of the complaints I hear more as a teacher, because here's the deal, y'all are students, and so you sit in classes and you listen to people like me lecture at you all the time. And far too often, We do not tell you to go research to make sure these things are true. And we just spout off things. And a lot of times our own biases come in. Personally, I think in 2023, our biases are typically, do I like Republicans or do I like the Democrats? And that's most people's bias. It's right there. It's not, do I like the Cowboys? Do I like the 49ers? Do I like the Rangers? Do I like the Astros? Most of our biases that color our teaching is typically, who do I want you to vote for in the future? And it's a crying shame. It's truly crying shame. Why do I premise with that? I want to tell you this. I hear so many students come to me year in and year out, or maybe they're not even talking to me. I just overhear them talking. I just interrupt and start say all the time, hey, well, I can't because I'm a girl. If I were a boy, I could do this. If I were a man, I could do this. In our country, I can't because I'm a girl, or I can't because I'm this colored skin, not that colored skin. I want you to know when it comes to this, buying companies and making money like this, it has nothing to do. They cannot discriminate against you. They cannot based off of your gender, based off if you're old or young. They can't off your color, your skin. They can't discriminate based off if you're a citizen or a green card or if you're here. They cannot discriminate on any of these things. If you purchase the company, you are the rightful owner in our country. That's how it works. We have private property, and you can complain all you want to in your other classes, saying, well, you stole it from the indigenous people. You did, whatever else, and you come in here colored by the politics. But I want you to know the fact. The fact is this. If you purchase a company and that company makes money, guess what? You make money. And you can go in your other classes and get all emotionally riled up and mad and everything and think you're going to change the world by voting for the next Joe Biden / Donald Trump, whatever it is. You can feel like that, but I want you to know that has nothing to do with your financial future. Nothing. So in my opinion, it's wiser for you to not care so much there. Not saying ignore it. I'm not saying that at all. But slow down your anxieties or your activeness in that regard and consider your financial future, because I guarantee it'll make a bigger impact in your life than who's the next president for the next 4 years. If that makes sense. All right. Let's look at some more. Let's go to part C here. Miss Hernandez owned stock in Apple. There's the stock symbol. You can look again. I'm throwing all this in there. If you're wondering why is he throwing in the stock symbol, so you can research to find that the things I'm saying are true. Okay, I encourage you to test. Am I telling you things from bias, or am I telling you things that are factually accurate? She owns 220 shares, each valued at $171.21 on September 29th, 2023. You can tell when I was making this lesson. For a total value of $37,666.20. If Apple has grown at 22.4% interest rate compounded continuously since her initial investment of this amount, how long has she owned the stock? Again, these are accurate numbers. When you find this out, you're going to find out the exact accurate number. All right. What did I give you? Apple. What type of company is Apple? Does it make money monthly, weekly, daily, or all the time?
Okay.
So which formula are we using? A per. A per. All right. What values did I give you? Let's start with 220 shares. Does that go in the formula?
No.
No.
So you could do 37,000 is your initial. Your initial. Your final.
There we go. That's the first thing they gave us. That's our final amount. So strip away the $sign and the commas. 37,666.20. I was almost scared to take that away. That's 666, but I thought the 0.20, maybe that'll save us from Satan entering this classroom here.
It's only been 666.
That's right. That was my thinking. So if Apple has grown at 22.4%, what's that?
That's our rate.
Meant to switch colors. Sorry. Let me try that again. This is going to be our rate. Now, will I actually type in 22.4%?
No, you can type in 0.424.
So divide that by 1. But when I say divide by 1, I mean by 100%. That is dividing by 1. And what do we get that as equal to?
0.
No, I messed up again. There we go. If you're gonna have a 0 in there, it goes before. You move the decimal 2 times to the left.
Yeah.
So 0.224. All right, great. What is compounded continuously? That's this formula. E means continuously. Since her initial investment of
That's P.
that's P. There's our P. strip away the dollar sign and the commas, 5016.65. E does not change. E is not a variable. It is a constant. It's that 2.72 value. We're going to raise it to the power of
0.2 more.
The missing variable would be t, right? Yep.
T. We don't know T.
Don't know T.
All right. So again, I haven't taught you how to solve these yet. So we're going to insolve. And if you're going to insolve, don't reduce anything. Straight up go from there. So we go to our calculators. I'm going to copy this formula down. No, I won't. Menu 3-1. What was the final amount? 37,666.20
Yep.
equals
5,016.65 cents.
E.
0.224.
And our T is unknown.
It's like every year, so.
Press enter. What has
9 years.
it's been exactly 9 years.
Well, yeah. How much did she make?
I say exactly. It's been approximately
32,000.
9 years. So yeah, you made approximately 32,000 in 9 years. Actually, let me change. I said you made. Did she actually make $32,000 herself? How much did she work for?
5,000.
5,016. And how much did she
Actually, get
passively gain?
32,000.
32,000 over how long?
9.
9 years. I know you feel like it's a long time ago, but it really isn't. If y'all think about it, y'all were in school. You were in grade school. You can think back 9 years. It goes by fast. If you go to college, I know a lot of y'all. What's going to happen? I'm not recommending this, but I just know the statistics here. A lot of you may go off to college and you'll spend the next 4 years hung over in class because you're drinking all the time. And those 4 years are going to go away that fast because you're not going to be sober for a lot of it. It's unfortunate, but statistically, that's going to be accurate.
How dare you?
And because of that, it's actually going to take you 5 years to get through. You're not going to do it in 4. It's going to take you longer because you're not in class enough, you don't whatever. So you go in 5. And here's what's going to happen is instead of earning this money, you're actually going to accumulate a lot of debt because you're not going to be earning things. You're going to be too busy partying. And all of a sudden, this formula is going to work against you. You're going to come out, and what's going to happen, statistically speaking, and this is why I really want to do this lesson, is you're going to come out and you're going to be someday maybe one of the people in the classroom railing on America how bad it is because you're going to have this value not in your pocket. You're going to have a credit card company holding the debt against you, and you're going to feel like you're a slave to the credit card company because you're seeing this thing grow. I had a friend literally maybe 2 months ago came over. So at my church, I do a lot of things with newlyweds, whatever, and they know that I've done this with enough people. Kind of have a reputation that if a lot of them, if they have financial things, they come over and talk to me so we can come up with a plan to help them get out of this financial debt. I had one literally 2 months ago come over. He has him and his wife, newlyweds, have approximately $23,000 worth of debt. You think, well, that's not nearly as big as this number. He is paying $900 a month to the credit card company. Do you know how much is dropping his monthly or his balance? $17. He pays $900 and it only drops at $17. Now, why?
Because of the compound
It
interest.
keeps
Because of the compound interest. How would you feel paying $900 a month and only watching your bill drop $17? Feels pretty unfair, doesn't it? Pay attention to what I'm telling you here. Don't go again. Statistically, I know everybody's gonna, but be wise. You can go spend your time in drunkenness and saying this is the greatest 5 years of my life. They're gonna go by fast, and you won't remember them, but you'll remember that debt. Think about it. Think about it. Sobering stuff there. What do we get here? Approximately how many years? Approximately 9 years.
You're stuck with reality bombs on everyone.
Yeah. All right. If the stock continues at this growth rate and Ms. Hernandez does not make any further transactions, what will be the value of her shares of Apple after another 10 years? So now we've discovered how long it's been. It's been 9 years. Now, how long are we saying?
10 more.
We want to go 10 more. So what's 9 plus 10? So we're gonna stay the same initial amount. We're not gonna mess with that, but now we're gonna say T is 10 plus 9, which is equal to how much? 19. So come back to your calculator. We're gonna take the same initial amount. So we still started, this did not change her initial investment. But instead of waiting only 9 years, she's more patient. She says, you know what? I can not withdraw for a little bit longer. I can continue on my normal salary. I can continue on what I'm earning. I won't spend more than I'm earning right now, and I'm going to continue that save. Instead of doing 9 years, we're going to go 19 years. What's the value of her $5,000 after 19 years?
353,000.
What the hell? Yep, 200.
Now, y'all, easy on the language. I know it's mind blowing here.
How's that, man?
So I'll put that so you can see that there should be a comma there. So we're talking now. Let me copy that over. Shrink it down so I can have that number. I'll put it right there. We're going to say now the value is 353,810. Let's walk through this one more time. And 83 cents. This is not realistic for you today because we can't predict the future. But this would be realistic for someone in what year was it? What's 2023 minus 9? 2014. This would be realistic if on September 29th of 2014, if you bought this amount, whoops, where is it? 5,000. There it is. And you did not touch it and it continues as it has. This is 100% realistic for that person. Okay. It's crazy. I'm saying it's crazy. It's the way it works. I'm about to blow your mind with a bunch of numbers here if we have time. Let me finish this up here. How many more do we got of these?
Two more.
All right, let's finish this up. Miss Johnson opens a credit card. Here we go.
Oh boy.
Here we go. The fun stuff.
Oh,
Let's start
no.
finding not how much money we have. Let's start seeing how we can become financial slaves to Bank of America, to Chase Bank, to
God, no.
whoever. You know,
I don't trust in credit cards.
Mr. Johnson opens a credit card with a 21.9% interest rate and a credit limit of $4,000. He is told that if he pays his balance in full within 1 year, he will not have to make any interest payments for this promotion. Credit card companies do this all the time. No interest for the first year, and you don't pay anything, and your balance stays the same. And it's like, man, I can just keep spending, and I don't even have to pay anything. That's how they sucker you in. So he will not have to make any interest payments for this promotion. If Mr. Johnson maxes out his credit card, that means he spends all $4,000 in the first month and chooses only to make the minimum payment of $25 per month throughout the first year. What will the balance be of his account after 1 year?
Uh-oh. So let's say
$1.
25 times 12.
So how much did he actually pay? So how much did he spend? Let's start there.
This is paid
Spent 4,000. He spent 4,000. Now, how much did he pay?
25 each month for his first year. 25.
So 25 times how many months are there?
Well,
What is that? $300. He pays 300. So what's his balance? So balance would be $3,700. You take the 4,000, you subtract what you paid. Spent minus paid equals your balance. So you have a balance of 3,700. Okay, so the first year comes to a close and you haven't made any extra payments.
and now that 21.
All of a sudden, here's how it works with credit cards. You haven't seen it change at all, and now they say we compound that interest. You didn't pay it off, we got to compound that interest. So now let's go see what you owe the credit card company because you did not pay it off within their promotional guidelines. This hits you. So here's what we're going to do. Does credit cards compound all the time, or do they do it a certain period of time? It's a certain period. What's the period? How often do you have to pay a credit card? Monthly. So am I using the same formula?
Yeah.
We're using this formula. AP 1 plus R over N to the power of NT. So what's our, we don't know the final amount. That's what we're gonna look for. What's our initial amount? Say 3,700. You got it, 3,700. Okay, 1 plus, what's our rate?
21%.
There's the rate.
Sorry.
So if we change that, it'll be
0.219.
219 over. How often do you have to pay a credit card?
12.
Once a month, so monthly. And we're gonna do this, whoops, N is 12, so you're supposed to make 12 payments. We didn't make them, we were supposed to, for how many years? Just one. T is 1. All right, let's go to the calculator to see what, we didn't pay it off in time. What does that happen to our balance? What has just happened? So 3,700 E. It was 0.219. Is that right? Times. No, I'm using the wrong formula. Goodness. All right, 1 plus
0.219.
219 over.
First year, your 3,700 becomes 4,596.
Now, so here's the deal. I want you to think about this. You don't have to multiply by 1, but I will. I want you to think about this. We bought $4,000 worth of stuff, right? We paid already how much of it? 300. Now, does it still seem like it was $4,000 worth of stuff?
No.
It's approximately, if this is about 4,600 and you've already paid 300, it's almost like you paid 4,900 for your $4,000 worth of stuff. Now that's with a promotion. That was still with the promotion. This only skyrockets. Yeah, go ahead. This only starts to skyrocket more and more. Let's go to the part B. So what's our answer here that we come up with? Sorry, let me write that down.
4,596.
4,000.
596 and 79 cents.
79 cents. Okay, that's our new balance. That's what I was just telling you about my friend. If Mr. Johnson increases his monthly payment to $100 a month starting in year 2, what will his balance be after 2 years?
That's gonna get really depressing.
Now, this is a tricky one to figure out. So, so this doesn't mean after 2 years. This means we're going to
After the, okay, so you went 1 year, you
Uh-huh.
paid off that, then the other year, that's your new balance, and then now you're starting the second year. After the second year, you're paying 100 a month.
yeah, I know it gets complex. So let's see what happens. So here's what happens. Let's go to our calculator. So that's what we now owe, right? So what I'm going to do is I'm going to copy this equation. And this time, I'm going to put this new balance here. It's 4,596. We're still compounding by 12, but now what we're going to talk about is what is it after 1 month? So change this to a 1. Now, that's compounded one time, but we make how much of a payment? Actually, come back here. I should have put it right here. How much of a payment do we make?
Minus 100.
Minus 100. So in here, what I want you to do is put a minus 100. So he pays 100 off that balance, but then the rest of it gets compounded one time. Press enter. What is it after 1 month?
What in the?
What? Bro took only like $12.
All right, so you're seeing my point. This is what the point is on this one. What happened? He paid 100. How much did his balance go down?
Only like 12 months.
I'm getting $18. That the payment went, the amount went down $18. So you paid 100 and only took off $100. You see how this is dangerous here? Okay, now copy this again, but this time change the 4,596 to the new balance, which is 4,578.05. That's our new balance. We pay $100 on it, but the rest of it compounds. That 1 means I'm only compounding for 1 month. So this is now month 2. So that was January. This is February. Now we paid $200. How much did our balance drop this time?
Or
Just a little over $18. Do you see the point here? Do you see what I'm getting to? Does a credit card seem so fun anymore?
no.
You're paying $100 a month and it's dropping $18 a month. See, that's going to take a long time to pay this off, isn't it? I'm going to stop this problem here.
Technically, like, okay, instead of paying $100 a month, if he manages to come up with $5,000, do you think you have to pay for it?
Oh, yeah. That would be the smartest thing. That's what I was trying to tell my friends over. So my friend came over and I told him before, here's your homework. You need to bring me a whole budget. That was the homework. Like, if me and my wife are gonna take time out of our evening to sit and talk with like 2 hours for this couple, it's like, hey, you gotta come up with your whole budget, come up, bring it up. And I started looking down, I'm like, okay, on Amazon, y'all spend about $400 a month.
Damn.
Stay off Amazon. And they're like, no, we need it for toilet paper, whatever else. I was like, okay, here's what you do. You're gonna set aside a certain amount of cash, and you're gonna go with cash. They use Kroger for their grocery shopping. I was like, you're gonna start buying it from Kroger, and you're gonna pay attention. You're gonna say, this is the amount I get to spend. And if you're looking up and you don't have enough money, you have to make the choice. Am I gonna keep buying Coke, or am I gonna buy toilet paper? Okay, well, this is what I'm
Necessities and wants.
exactly. This is what I'm getting at. And I just try to walk them through it and start realizing, okay, well, do you really need cable? Yeah, I need cable. You do? You really need cable. Okay, you really need cable. All right, well, just know that's $130 that it's costing you a whole lot more because you have to do it on credit card debt. And it's not actually $130 anymore. It's gonna cost a whole lot. And that's what I was trying to walk them through of how this works. Does that make sense? The whole point is, let's save as much money as we can now and pay down the debt as fast as we can. Don't pay $100 a month. If you're saving a total of $472.13, throw all $472.13 against that debt to start taking it down quicker. Does that make sense? That's what I was trying to encourage them to do. Do I have one more here?
Yeah.
I do. I want you to see this. So you're purchasing a home valued at this amount. The mortgage rate as of October 1st, 2023 is this amount right here. That's what it is for a 30-year fixed loan. If the Gonzalez put down 20% at closing, what will their monthly payment be? So this is a crazy formula. You do not have to memorize this, but I just wanted to show you this because it's good education. We're going to find out how much. We're going to find out how much does it actually cost to buy this 350 grand home. So you see the price tag. How much is the price tag for this home? By the way, I was Googling, that's approximately the Texas median home right now.
Yep.
So median, what median means, just so you know, if you think, well, no, I don't want median, that's what occurs most often. I want the average, that you don't buy a house on the average. You have some houses that cost 6 million and throws it off. You want median. What occurs most often? What am I most likely to see if I go to buy a house? $350,000. Okay, so here's a problem. It says we pay 20% down. That's what, if you don't want a higher interest rate, you need to come up with 20%. So what is 20% of 350,000?
3% of 300,000. All right, just multiply it by 0.20.
We multiply this by 0.20 and you're gonna get 70,000.
It's not bad.
So that's what you put down up front.
Down payment.
So how much are you actually paying?
28.
This is what we call the down payment. So how much are you getting a loan for?
$280,000.
350,000 minus 70,000 is your loan's actually for $280,000. That's what your loan's actually going to be for. We want to know, how much does that mean you're actually going to be paying monthly? Here's our crazy formula. Y'all ready for this crazy formula?
Yes.
Let's do this. I'm going to just delete all that out of there. All right. The crazy formula. Here it goes. Our monthly payment will be, do a fraction first, control divide. What's our principal of the loan? 280,000. 1, 2, 3. Times, what's the rate? The rate comes next. 0.269. How often do you pay payments? N is 12. Okay. Over parentheses 1 minus parentheses 1 plus, and no, you can't simplify that. Control divide 0.08269 over N, which is 12, all raised to the power of -12 times, how many years are we doing this loan? 30. Press enter. This tells you your monthly payment. How much are you paying monthly? $2,107, and I'm around to 29 cents. $2,107 and how many pennies? 29 pennies. So practically speaking, let's find out how much our house cost us. If that's our monthly payment, we make this payment. And how often do we make that payment? You do it for 30 years. And how often do you only pay once a year? You pay 12 times per every year. Does that make sense? So 30 years and you're making that payment 12 times per year. How much do you actually pay for that house? Do you pay $350,000? You pay that amount plus the $70,000 you already paid. Your $350,000 house that you felt so good about because you felt like you got a steal is actually $828,624.40.
$1 million. What the